Alright, let's take a look at a CodeWars problem. Today when I visited the homepage, this one was waiting for me, and I decided to go with it. Let's see the directions. It says, sum of the first nth term of series. Your task is to write a function which returns the sum of the following series up to the nth term. And the series is 1 plus a quarter plus a seventh plus a tenth plus a 13th, and so on. You can imagine the first one as being 1 over 1, which means the top is always 1 and the bottom is 3 more than the last, so 1, 4, 7, 10, up to n, which is how far we're going. And there are more details, but I think it's easier if we just start and see what happens. The way you get any CodeWars exercise is the function definition. Sometimes this is called the signature, and then a blank canvas to write in. I'm going to start with the long way, the way that lays out every step, and then condense it into something nicer. Whenever you look at the solutions on here, you'll see a lot of people have these beautiful one-line expressive solutions, but you don't get there on the first try. You write the brainstorming first draft and then you boil it down. So often, maybe every time, your long way, your first try is going to be a for loop. So let's make a for loop. For, what's the thing that's changing? What's the thing we're working with? And that is the bottom of these fractions, the 1, 4, 7, 10. And the bottom of a fraction is called the denominator, but I don't feel like typing that whole thing, so I'm going to shorten it to denom. And then we have a range describing what pattern this follows. It starts at 1, and that's important because by default range starts at 0, which would not work for a denominator. If we tried to have a 0 in there, it would divide by 0 and immediately crash. And then how far do we go? Well, it's not just n because, you know, the second one is 4, the third one is 7. We have to do a little transformation. And what it ends up being is 3 times that plus 1. So we need, in this case, 3n plus 1, which is 1, 4, 7, 10, etc. And then finally, the last parameter, when we talk about a range, it's start, stop, step. So the last parameter is how much do we go up each time, and that's a 3. The name they give to each little fraction, each little chunk, is the term. And so the term is just 1 over denominator. That's very nice because the range does all the work. All the calculation is done in there, and all we have to do now is just accumulate them into one thing. So we could call that a sum, and we just add the term. That means we need to start it out as 0 and return it at the end. That's the pattern we're following. We're going to start at 0, add each one. When we get to the end, we return. And what do we know at the end is? Well, it's given to us as a parameter. So if I hit test, that will show me what's going on, and it'll tell me that our first two are okay, where we're getting the right answer. It's 1, or it's 1 1/4, and the next one is 1 1/4 and a seventh. And we are adding that up correctly, but they want it rounded to 2, and they want it as a string. So we failed them all, but we're close. We just have to add one little thing. Throughout the class, we've seen a couple ways to do this. There's a function called round, but that gives you a float, and we want a string. So I'm going to use my favorite method, which is the f string. If you put a .2f, then it will format it as 2 floating point decimals, which is what we like. So now if I hit test, it's going to pass everything, and I could send it along, get to the next page, which is everybody else's solutions. But I want to talk about what we're going to see when we get there, because we're not going to see much of this. We're going to see a different style. and that is, well, there's actually one problem before we get there. The sum name is a bad name because in Python there's already a function called sum, and we want to avoid stepping on its toes. We don't want to use the same name. That would be confusing for anybody who's used to sum meaning one thing and then here it means another thing, and that would mess them up. Also, instead of avoiding it, we could lean into it and just use the sum function, which is what I want to do here. After all, it's what we're doing. It's the first word of the title. It should be the first word of our solution if we can set it up that way. I would like to rearrange this stuff in a slightly different way and show you what I mean. If we take the sum of this for this, then we don't need a loop, we don't need any of that, and we don't need to start at 0 because the sum function can handle this kind of expression. This is technically called a generator, but it's the same exact syntax we learned with the list comprehension. It's not new. And then we could go ahead and just peel this off, wrap it around, and we're done. This is a one-line solution, and unless I made a mistake, it's going to pass the tests. Now, it's a little too long. You might want to remove some spaces to squish it in. And you don't get any points for a one-liner. You don't get any points for shoving everything into one step. But I think there is a reason why people like these, and that is it says what matters in order. So what is this function about? It's about sum. So we say sum right at the beginning, and it describes what happens. And then what are we summing? It's the fractions. So we say the fractions right after that. It's not hidden 4 lines later, indented in a loop with some other stuff. It's front and center. And then we follow it up with the details of how and where. But the important part is it's the sum of fractions, and so right at the beginning we say the sum of fractions. In fact, now that this variable is on the bottom of a fraction, we don't really need to call it denom anymore because it's at the bottom of a fraction. Of course it's a denom. So we could shorten it to an I or something like that, which makes the whole line fewer characters. At first we used denom because we had to say what we were going to do with it later, but now we don't have to say that because we're doing it front and center. So I would like to submit this, and my only gripe, my only thing I'm not happy with is the format. When we have the F over here and we don't describe the formatting until the other end of the line, those are a little bit separate, and I would love to do them together. Otherwise, I'm happy with this. And if we see what other people have done for their solutions, we'll see the first two are the things we covered. Here's one of them who did it with the sum and an expression of what kind of sum, and here's one who did it with the loop and starting at 0. Now they're not the same as we tried. Okay, this one uses the string dot format, and they also use a plain range and then adjust it every time. And this one uses a little bit of a different addition than we did, but those are the two patterns you'll see. If we scroll down, there will be a bunch with sum and then the expression of what we're summing, and there will be a bunch with 0 and then a for loop doing it. The details are not super important. In fact, they can be wrong. Like this is a Python 2 thing. It's an old version that you wouldn't want to follow. But seeing the general approach is super important. Eventually, if we scroll down long enough, we'll see some other one, some unique variation that uses some other tactic. But here's one. This guy used the same idea, but written in a different way. So when we do this type of expression here, we're saying, what are we going through and what do we apply to each one? And map and lambda do that in a different way. So map says, hey, we're going to apply something to a list or a sequence, and then lambda says, what is the thing that we're going to apply? You're writing a little baby function to be used right away. Now, the next one has a fraction module thing that I've never heard of, but maybe it was useful for this person. And you can see some little details, but I don't want to think about the little details. I want to think about the big picture, which is that there are basically two ways. We either start at 0 and add one at a time, or we sum and then we express what we're summing. These are not at all unique. In fact, probably half the problems on here could be described the same way, where you can either do a for loop or you can do some kind of functional expression. So really take time whenever you do a CodeWars to look at what other people have submitted. When you get to this page, you know they're good. You know they've passed the tests. And it doesn't mean you have to follow them in the future, but it means you'll get the breadth of possibility. Look, this person did exactly the same as I did, and that's my twin out there thinking the same way. Now, whenever you do another one, it has a good chance of following the same pattern, so keep it in mind.